Hello and welcome to another DAC Band Productions video. I had requests from a few YouTube subscribers, a little bit more information on this swing out bridge that I created. So they were a little bit more interested in how I built it and so forth and so on. Let me put a disclaimer right away that this bridge is not the most detailed one in the world, and I decided to build this bridge in such a way that it would be quick and fast, and I didn't want to be spending the next year just building a detailed bridge because I wanted to be up and running on 072. So this is basically a real basic, quick, easy build bridge if you're sort of like in a hurry, and you can always build a once you get the basic foundation down, you can always build onto it or build a more detailed bridge later on. So with that in mind, keeping that in mind, that I wanted to build something quick, fast, and easy so I could keep moving on, updating my layout to 072 so I can be up and running, I decided on a girder type of bridge to have as a swing out bridge. Some guys don't like girder bridges. Some of them want truss bridges, which is fine. They look cool too, but like I said, I didn't have that time. I didn't want to spend that kind of time doing it when I was updating my layout. So I used wood, basically wood shelving as a foundation for this build. 6-inch wide regular wood shelving is what I used that I had laying around, so it's not really made of anything fancy. The logos that you see on there, Conahey rail, let me get close up on there. So the logo Conahey rail, I made that on a printer. The Conahey rail established 2015 were just some lettering I found at Walmart and stuck on there. Like I said, nothing fancy. The 12.6 bridge height sign, I made that on a printer. And then the caution load clearance, I also made that on a printer. The yellow outlines were actually made from roadway lines that are sold on eBay. I decided to paint the bridge black to hide a lot of the imperfections or whatever have you. So I decided to paint it black instead of like a Tuscan or whatever have you. And I ran into quite a few Conrail bridges that were actually black anyway. So now we will go on to the basic concept of building this bridge. So the biggest challenge for me on this bridge build is I had to do it on an angle with a curve exiting and a curve entering. So because I have a curve exiting and entering, I had to make the bridge wider than what prototypically they would normally be if there was a straight piece of track going through there. If you have the room, make sure your track is going straight in and straight out. But unfortunately, I just did not have the room because 072 are pretty wide curves. So for me, I have 072 curves coming into the bridge and 072 curves exiting the bridge. The way I was able to overcome any cars hitting the walls in an overswing situation, especially for your 89-foot and 86-foot scale cars, I made the bridge wider than you would normally have it, and it does clear now. So I wanted to let you guys know that as well. So I'm sure the biggest question you guys are asking is, how did you power this bridge up? So there was 3 things I wanted to do or wanted to have as far as features with this bridge. I wanted to be able to have it in place, I wanted to be able to swing out of the way, and I wanted to also be able to totally remove it if I so choose to do. And I accomplished all 3 of them and I'll show you how I did it. Alright, so let me show you how this bridge works. Like I said, I built it to have it in place, to swing out of the way, or to totally take it out. So, I'm going to show you first how it swings out of the way. Basically, you just lift it up like so, and you can swing it out of the way. And what's nice about the way I did this is trains can run underneath here while the bridge is swung out of the way. So as you can see, now that it's swung out of the way, trains can literally run under the bridge and go through the horseshoe. I also left the option to totally take it out altogether. Now some guys design their swing out bridge so they have to hold it in their hands, or they got to put it off to somewhere, and I didn't want that. I wanted to be able to swing it out of the way and let it rest on its own. So I decided to put it on these posts here, these tubes. And I made these tubes out of, just regular metal plumbing, metal tubes that slide in each other. And then mounted it onto a base that I created. And then I blocked it in with wood. So you have to walk around it, and I'll show you why. So the way I wired this up, I can take this out without having to unplug a million wires or any wires. I don't have to unplug anything, and I'll show you how I did that. So I'll show you here. I can actually take this out, and now I can store this away. I can put a piece of wood on top of that and then use it as a shelf or whatever have you. And then, of course, on top of the wood, I have a bumper to keep, in case somebody forgets to switch the switch. This part of it is dead until the bridge is in line. And if the train still comes through at speed, there will be a bumper here with a cushion on it to stop it from coming off. So there are some safety guards that you want to consider when you're building a swing out bridge. If you forget to throw the switch, you don't want your train ending up on the floor. But we will leave this here like this so I can show everybody. Actually, I'll leave it like this. How this is built. Alright, so there is a double ball cabinet latch on each side of this, the male part of it, with a wire. You can't see the wire because I sort of like painted it, but here it is here. One will go to your center rail, and then the other end will simply go to your outside rail. So your positive will go to your center rail, your negative or return goes to an outside rail, which will be on the other end. So here in the bridge, that male part that I was showing you will go inside and make contact. This part of it, the female part of the double ball hinge or double ball latch, is live. So once you remove the bridge is dead. But once you install the bridge, it's automatically live. So one end, like I was explaining of the bridge, one end of the bridge will be power. The opposite end of the bridge will have your negative. So basically, I pulled wire or ran wire off of the track, and then ran it to this double ball cabinet latch, which you can find on Amazon pretty cheap. They make them in brass, they make them in stainless steel. You can actually see where the male part slides in at. And you can see how I connected it. So that stays live all the time. Then I created one on this side of it. So like I said, there's one on each side of the bridge. Once the bridge falls into place, it's got both power and negative. so the train can run through. As you can see, I just built the bridge out of scrap wood that I had, scrap shelving. You can build yours out of metal, out of aluminum. There's different materials to use. But there you go. There's my wire that comes out to the male part of the double ball hinge, and that goes into the female part. And there's one on the other end of this bridge as well, down at the bottom. Okay. The advantage of doing this, of just doing it this way, is you don't have to disconnect any wires to remove the bridge. You just simply remove it and that's it. It's dead. As you noticed, instead of making my track dead even with the bridge, I overlapped it. And I did this purposely on both ends. The reason for overlapping it is to help prevent the bridge from sinking further than what the actual track is that you're trying to run with. So if you were to make this even, and if your layout settles or if the bridge settles later on, your track could end up being a little bit lower than the track on your main layout that you're trying to match up to, then cause derailments. So that's what I did to help prevent that, as well as stops, of course. But that's what I ended up doing, is just overlapping. So once this bridge comes around, and I'll show you guys this, because I can actually do this one-handed the way I designed it. So it swings around, and as this is coming down, you'll see what I'm going to talk about here in a minute. That's going to overlap the layout here. And as you can see, by overlapping it, it sits right on top of the layout to better match your track. That's on the main layout. Yeah, there are stops under here as well to help prevent sinking, but you never know. And the same way over here, you can see that it overlaps here as well. So it slipped in pretty easily one-handed, and that's another reason why I designed it using a post. Of course, the downfall is that, you know, unless you enclose the post like I did, it could become a trip hazard or whatever have you. So that is the downfall to that design. But that's the way I wanted to make my bridge. So I'm going to pull this out, and you can see the inside here. I didn't get too fancy with it. Like I said, my main goal was to get my layout up and running on 072, and I really didn't care about details at that time. I can always go back and create something better or whatever have you. I just took some scrap model wood and tried to create bracing for the girder bridge. I mean, it's not realistic spacing, it's not to any kind of prototype. Like I said, I just built it to no standards, because I was in a hurry, and I can always change that later on, or add the correct amount of girders, or build a truss bridge, or do something different. But I'm just happy to be up around 072. But I know there was people wanting me to shoot a video of how I created this. And you can see the, I don't know how well you're going to be able to see if it's dark in there or not, but you can see, yep, you can see there. But you can see the post goes down to a base that mounts. So as I said, the one thing I like about this design that I did is that you can handle the bridge and take it out with one hand, as you've seen on the video. And you can leave it in, and trains can run underneath of there, or you can take it out altogether if you don't want to run 072 at the time. So I hope this answers questions for all you guys. And what I did is I ended up soldering my feeder wires off of the pin. I found that to be the best way of doing this. Soldering feeders for the ball stud attachments that you see underneath. So Gargraves does sell feeder terminal ends that are already soldered on the pins, but I do my own. It's a lot cheaper. So that's how this is getting power and ground or return. So here's your power. You can see I soldered the wire to the pin, and then over here, here's the wire soldered to the pin on your ground or return. Easy enough to do, but if you're not good at soldering, Gargraves does sell wires already soldered to terminals. I think they're like $7 a shot though. So I hope this answers the questions that a lot of viewers had on this particular bridge build that I made or did. If you're looking for a quick, easy, basic bridge to build, this is one way to go. By the way, I thank you viewers for tuning in and watching Conahey Rail on Deckman Productions YouTube channel. Conahey Rail was I started to build it in 2015. Then I decided that I wanted Conahey Rail to become an O-gauge high rail layout, and then so I took all my traditional trains off there and built the separate layout for those. But I thank everybody for watching Conahey Rail videos, and thank you guys for all your comments and questions, and keep them coming. And if you have any requests, I'll try and shoot videos of the things that you guys are asking about that I have here. And see you guys later.